Okay, so we are going to talk about trig. Primarily, we're going to be talking about the unit circle. So we're going to do an intro to trig. Um, and the big thing that you have to take away, I mean, there's all kinds of stuff you can learn from trig that is helpful. In terms of what you have to know when you get into calculus, you got to know the unit circle. So before we go into that, I'd like to give you a little bit of background, and then we'll go from there. So the first thing that normally you learn in trig is the phrase SOHCAHTOA. And SOHCAHTOA stands for sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. And what are these referring to? Well, it's in reference to a right triangle. So in a right triangle, you have a 90-degree angle, and then we're on the lookout for something called theta, and that's the angle of interest. So we're going to draw this triangle twice. And we have theta located in two different corners. So no matter what, the hypotenuse is always the hypotenuse in a right triangle. And then the side across from theta is the opposite, and the side that we haven't touched yet is the adjacent. Okay, so you can answer all sorts of problems with ratios and this and that and whatever. But this is the intro of where these ratios are actually coming from. Something else we should be familiar with in trig, we should know the Pythagorean theorem, and that is a squared plus b squared is equal to c squared, also known as leg squared plus leg squared is equal to hypotenuse squared. So these are all some intro things that should pop up in trig that make sense. So before we jump into the unit circle, I'd like to try and show you what's called the special right angle triangle ratios, basically is what they're called. If we take we'll start with, let's start with this square. And if we say that it's a square, so all the side lengths in this square are 1. And if I chose to, I could cut this square in half diagonally, and now we've made a right triangle. So I'm going to pull this out, and we're going to examine it a little further. So we got 1, 1. But now what did we do to our angles when we did that? So originally it was a square, which meant all of these were 90-degree angles, right? But then when we cut it in half, that turned this into a 45, 45, 90. Okay, so now I'm interested in finding this hypotenuse. Well, how would we go about finding that hypotenuse? We have a formula for that, right? Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared is equal to c squared. So if you run that over here, this would be 1 squared plus 1 squared is equal to your hypotenuse squared. So that gives you 2 is equal to your hypotenuse squared. So that gives you root 2 is equal to the hypotenuse. Okay, so why is that important, you might ask? So when you're looking at a right triangle in a 45, 45, 90 triangle, this should hopefully sound familiar to you guys from pre-calc, but it's always x, x, x root 2. So that pattern consistently holds up in 45, 45, 90. So these two are the same, and then whatever they are times root 2. So in other words, 1 root 2 is going to be the length of the hypotenuse. Okay, now let's go through and locate the sine of 45, the cosine of 45, and the tangent of 45. So this is kind of giving you some backstory on where these things are coming from. So if we look at this triangle, we've got the ratios, right? We'll pretend like this one that I just circled is your theta. So if I want to find the sine of 45, what do we know about sine? We just talked about these trig ratios, right? Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so if we go through this, what would be the sine of 45? Opposite over adjacent is 1 over root 2. And then if we rationalized that, that's multiply the top and bottom by root 2. That would tell us that the sine of 45 is root 2 over 2. Okay. If we look for cosine, you're going to see it's the same exact thing. Root 2 over 2. And if I look for tangent, tangent is the opposite over the adjacent. 1 divided by 1 is 1. Okay, so in a minute, we're going to need to access all of this information. Now, do you have to replicate what I'm doing right now? No, not really. I'm just trying to give you some backstory, give you a little bit of, idea of where this stuff's coming from. And we can do the same thing with the 30, 60, 90s. So if I drew a triangle, let's say specifically an equilateral triangle, and let's say that it had side lengths of 2, 2, 2. And that means if it's equilateral, its angles are going to be 60, 60, 60, right? And then so if I cut this down the center, we're going to do the same thing and just replicate the half that I'm interested in. So let's re-sketch that. Okay, that makes this a 90-degree angle. I'm only looking at this side of the triangle. This did not change, so that's still 2. Now, what else changed? This 60, that didn't change. This was 60, but I just cut it in half, so now that's going to be 30. This down below had been a length of 2. We cut that in half. That's going to be 1. Okay, and the last thing we need to do is Pythagorean theorem to figure out this other leg. And if you went through and did that, you would come up with radical 3. All right, now from this triangle, we could find the sine of 30, the cosine of 30, the tangent of 30. We could also find the sine of 60, the cosine of 60, and the tangent of 60. All right, let's go do that. So if we're looking at 30, the sine of 30 is opposite over hypotenuse. So that's going to be 1/2. The cosine of 30 is going to be the adjacent over the hypotenuse. So that's root 3 over 2. And the tangent at 30 is going to be the opposite over the adjacent. That's 1 over root 3. If you rationalize that, that's root 3 over 3. Okay, so these numbers should sound very familiar to you. You guys have taken pre-calc, right? So like you've seen all of these. If we go with 60, it's going to be root 3 over 2 for the sine. It's going to be the cosine is 1/2, and the tangent should just be root 3. All right, so that is the backstory on where this information is coming from for the unit circle. So I am just going to pause for a second, zoom out. If you want to take any pictures, write anything else down. That is like all the background information that we're going to be talking about. And we're going to pretty much just take all this information, add a little more to it, and out is going to pop the unit circle. So I'll stay quiet for a minute and then we'll resume. Okay, so let's talk about the unit circle. So um, you should be familiar with this because we've all taken pre-calc, but to make sure we're on the same page here, draw your best circle. Um, this is something that you have to know inside out. Like within 10 seconds, you should be able to answer anything that exists on this circle, maybe 15, 20 seconds. But if we're taking minutes on end to figure out the sine of 30 and this and that, that means we need to practice this more. So you're never supposed to have memorized, and I don't advertise this as something you should memorize. I advertise it as something you should be able to quickly work through. Because if you try to memorize the whole thing, it's kind of too much. And then we end up just confusing it and messing up different parts. So this is the unit circle. This is my explanation of how I teach it and how to try to make sense of it. So the unit circle has 4 quadrants. So we are going to divide the circle as such. All right, so really try to focus in on this for the next 15 minutes or so as we go through this, because this is really, really important that you can kind of understand this logic and use this next year. So when we're starting at a circle, it's at 0 degrees. And then hopefully it makes sense up here that this is at 90 degrees. This would be 180 degrees. This down here would be 270 degrees. And then over here is 360 degrees if we've completed the circle. Okay, now think about the angles we just talked about when we were doing that backstory. Those angles were 30, 45, 60. And those are the angles that we're going to incorporate as we go around this circle. 30 degrees, 45 degrees, 60 degrees. And we want to think of these angles as a 30, 45, or 60 everywhere we go on this circle. It'll make life way easier. In other words, always think of things in terms of the distance they are from the x axis. So from this x, how far away are we? So in other words, if I go to this one, this one, this one, and this one, the ones that are closest to the x, those are always going to be our 30-degree angles. I'm trying to get a colored marker here to highlight that for us. So the ones that are closest to the x, those are always going to be your 30s. The one that's in the middle is always going to be your 45. And the one that's furthest from the x, keyword from the x, not the y, from the x, that's going to be your 60. So if this is a 30-degree angle, just think of it though in perspective from 180. Hopefully that makes sense to say that that's 150, that's 210, and that's 330. So you don't really have to memorize anymore. The one closest to the x is a 30-degree angle. Okay, the one in the middle of each quadrant is a 45-degree angle. So that means that we're going to be at 135, 225, and we're going to be at 315. The one furthest from the x is 60 degrees. Okay. All right, so that takes us to 120, 240, and 300. So that is the first lap of the unit circle. The first lap of the unit circle is the degrees. Okay. Next comes the radians. So when we're talking about radian measurement, one way you can think of it is the circumference of a circle. So some notes on the unit circle. First off, the radius of the unit circle is equal to 1. Okay. And when we're talking about the circumference of the circle, circumference is equal to 2 pi r. So a real brief explanation on this is that if the radius is r, the circumference of this circle is 2 pi. And if that is the case, we can say that in radians, the end of this circle is 2 pi. And for that reason, 180 degrees is equal to pi, because that's half of 360. So the key that I always tell people to memorize is we want to memorize that 180 degrees is equivalent to pi. And if you know that simple fact, we should be able to go around this whole circle and figure out everything. So now this is where you really want to listen in and make sure this makes sense, because there's a lot of ways to teach this stuff. And some of them are easier than others. And I like to think that this is pretty straightforward if you're listening and you can do a little bit of math in your head. So all we're going to say is we're going to make a comparison. And I'm going to say 30 is what fractional piece or fractional part of 180. And if you don't like that, say how many times does 3 get rid of the zeros? How many times does 3 go into 18? And you should be telling me it's a sixth of that, right? 30 goes in 6 times. So for that reason, it's a sixth of pi over 6. It's a sixth of 180. Okay, how about for 45? When we're doing 45, we want to say, well, how many times does 45 go into 180? And to figure that out, think of it this way. How many times does 45 go into 90? Your answer should be 2. So 2 45s make 90. So 4 45s make 180. And that's going to be pi over 4. Okay, we're going to go through the same logic now. 60 degrees, that's going to be pi over 3. 60 goes into 180 3 times. 90 degrees, that's going to be pi over 2. That goes in twice. All right, now, once we exit quadrant 1, we got to change our logic up a little bit. Like, yeah, we could still keep doing it, but the math would get a little harder to come up with, whereas in quadrant 1, that's pretty easy. Okay, after we exit quadrant 1, all we're going to do is say, what type of angle is it, and how many of them do we need? Okay, so remember what I said. The one closest to the x is the 30. The one in the middle is the 45. And the one furthest away, that's our 60. So what type of angle is 120? You should be saying it's a 60. Okay, next question. How many of the number 60 do I need to create 120? How many 60s make 120? You should be saying 2. So it's going to be 2 pi over 3, 2 of the pi over 3s. And you can use that logic for the rest of the circle. Next up is 45 degrees. How many 45s make 135? 3 pi over 4. Next up, this is a 30-degree angle. How many 30s make 150? 5 pi over 6. And we're going to use that same logic round and round. Next up, 210. What kind of angle? It's a 30. How many 30s make up 210? 7 pi over 6. 225 is a 45. How many do we need? 5 45s. So 5 pi over 4. For 240, it's a 60. How many 60s do I need to make 240? I need 4 of them. 4 pi over 3. For 270, you can pick whichever one you want. I would go with 90 in this case. How many 90s do you need to make up 270? You need 3. So that is 3 pi over 2. For 300, that's a 60-degree angle. So how many 60s do we need? You need 5 60s to make up 300. So 5 of the pi over 3s. For 315, that's a 45. We need 7 45s. So 7 pi over 4. For 330, it's 11 30s. So 11 pi over 6. And for radian measurement, it's either 0, 2 pi at the beginning. Does anybody out there have any questions that they want to ask on how I have come up with anything that you see? Okay, the last round to the unit circle is we need to come up with ordered pairs. Good news, we already did that, right? When we were talking about these background stories, we already figured out and showed you where all this information came from. All we're going to do is just transpose it now onto the unit circle. So what do we know about the ordered pairs for a unit circle? Instead of x comma y, in our circle, it's going to be cosine, comma, sine. So you can look back at where the answers came from earlier in this explanation. And now we're just going to kind of put them on here. So for 30 degrees, it's root 3 over 2, comma, 1/2. That's cosine and sine. For 45, it's root 2 over 2, comma, root 2 over 2. For 60, it's 1/2, comma, root 3 over 2. All right, so we got to talk first because there's a little memorizing involved here, but we want to look for patterns and try to make this as easy as we can. So what do we see at 30 and 60? It looks like the same exact thing, right? They're the same ordered pair, but they're just flip-flopped. So what we're going to do is we're going to memorize the ordered pair for 30 degrees, just outright. You got to memorize it and then flip it for the 60. So it's memorize the 30, flip it for the 60. And then we're going to memorize the 45. And the 45 is easy, right? Because it's the same thing twice. So memorize the 30, flip it for the 60, memorize the 45. Now, it's pretty obvious that something that would easily be confused is the 30 and the 60. And I want you guys to remember that 30 starts with a 3, and the first part of its ordered pair starts with a 3. That won't solve all of your problems, but it should prevent you from starting with 1/2, right? 30 starts with a 3, its ordered pair starts with a 3. So we're going to memorize the 30, flip it for the 60, memorize the 45. And if you do that, you don't need to know any other ordered pairs around the circle. They're going to be the same answers with these symbols. Now, hopefully these symbols make sense to you based on quadrant location, right? Where stuff is at. So in other words, all of the 30-degree angles have this ordered pair. So at a 30-degree angle, it's going to be root 3 over 2, comma, 1/2. Root 3 over 2, comma, 1/2. Root 3 over 2, comma, 1/2. The only thing you have to do is add in these symbols. So for the one at 150, that first one is negative. At 210, they are both negative. And at 330, just the last one is negative. And so now you can do this on your own time. I'm not going to copy these all over the place, but that should make sense on where those are going to come from. And then after that, we need to tackle the four corners. And when you're tackling the four corners, the 0, the 90, the 180, 270, all right, we want to pretend that you're looking at a XY grid, like an XY axis, like you're back in algebra, and you're just graphing, right? If this is 0, 0, where my pen's at right now, we'll call the center of this circle 0, 0. And we just said a second ago that the radius of the unit circle is equal to 1. So if the radius of the unit circle is equal to 1, what can we come up with here? We could say that this ordered pair is 1, comma, 0. If this is 0, 0, and I just go 1 unit to the right, the X value is now 1. The Y value didn't go anywhere. For the 90-degree one, it's 0, comma, 1. For 180, it's negative 1, comma, 0. For 3 pi over 2, it's 0, comma, negative 1. Okay. All right. Something else that you need to know in trig. You need to know that tangent is equal to sine divided by cosine. Tangent is equal to sine divided by cosine. All right. So what do we know about this unit circle? We have sine and cosine in these ordered pairs. So tangent is equal to the y value divided by the x value. And when you go through and do that, let's do this first one. 1/2 divided by root 3 over 2. Let me do that on scratch paper for you. If we divide 1/2 divided by root 3 over 2, we make what I call a 4-story fraction. And this is a very good shortcut to know when you're doing math. It'll save you time. If you have a 4-story fraction, let me give you a different one. If I told you A over B over C over D, that is equal to AD over BC. So for our example, that's going to be 2 over 2 root 3. And if we simplify this, that's 1 over root 3. And if we rationalize that, it gives you a final answer of root 3 over 3. So the tangent value at 30 degrees is root 3 over 3. Okay, for 45 degrees, what can you tell me? These things are exactly the same. So the same exact thing divided by the same exact thing, the tangent value is going to be 1. At 60 degrees, you would go through and do the same math, and the tangent value works itself out to be root 3. Now, this is easy enough to watch me do, but when you're on your own, this takes practice, guys, right? Like nobody just heard all this for one time and just sat down and knew all this. You got to practice this, do blank circles, scratch paper, do it again, check back, do your answers again, do it again. You know, if you do like 10 of these circles over the course of summer, you should really start to have it. But mastering the unit circle, it takes some practice. When you're looking at the corners here, 0, 360. Well, what do we get for a tangent value here? This is 0 divided by 1. 0 divided by a number, that's okay. That gives you 0. But when you go up here and you get 1 divided by 0, well, then that's going to be undefined. So your 180 would be back to 0. And then your 270 number, that tangent value there would be undefined. Okay. So zooming out, that is the highlights of the unit circle. We've now talked about factoring, logarithms, exponents, and a crash course through trig in terms of stuff that you really want to be fluent and good at coming into trig.